So to solve this like you would solve a normal equation, add 8 to both sides. So get 3 cotangent theta equals -3. Divide 3 from both sides. So cotangent theta equals -1. And then if you have trouble, well, let's see. Yeah, I think this is going to be easiest. Cotangent is the reciprocal of tangent. Right, so we can use that definition. You can multiply both sides by tangent. And now you can divide both sides by -1, or multiply both sides by -1 if that's how you think of it. So we have tangent theta equals -1. So this is one of our special trig triangles. Because if you're trying to find where the opposite over the hypotenuse is -1, then they both have to be the same, right? Say this is your reference angle. The opposite over the sorry, I said hypotenuse, that is wrong. The opposite over the adjacent. Those need to be the same because tangent is opposite over adjacent. So we need the opposite of the angle divided by the adjacent of the angle to be the same, and that special triangle is the square root of 2 over 2 triangle. So I get 45 degrees here, 45 degrees here. And this is these solutions also happen where tangent is negative. So if you use that mnemonic device we've had in these videos, all students take calculus. They're all positive here. Just sine is positive here, so let's draw a reference triangle because tangent will be negative here. Tangent's positive here, tangent would be negative here because just cosine is positive here. So if that's 45 degree angle for a reference angle, that means we have 135 degrees, so theta equals 135. And the other angle we have 360 subtracted by that 45, then the other angle is 315 degrees. -5 square root of 3 cotangent theta plus 1. Let's solve it like a normal equation. Subtract 1 from both sides. Let's divide both sides by -5 square root of 3 to help us get theta by itself. So that gives us cotangent of theta equals, now 15 divided by -5, we're going to say -3 over the square root of 3. Let's see what we can do with that. So let's rewrite just like we did with the last problem. Cotangent is 1 over tangent. So multiply both sides by tangent. And then trying to get tangent by itself, so let's multiply both sides by the reciprocal here. So that's negative square root of 3 over 3 equals tangent theta. I'm trying to think which angle this is. I don't know off the top of my head. I know it's going to be the 30-60 triangle though, because we have a square root of 3. Right? If this is a 60-degree angle, then our triangle has square root of 3 over 2 as one of the sides, and 30 has 1/2. That's just one of those triangles that we memorize in the unit circle. So in order to make this angle happen, what could we do? If we had, maybe, we could flip 1/2 and square root of 3 over 2 in terms of the reference angle. What if you did 1/2 divided by the square root of 3 over 2? That'd be 1 over 2 times 2 over the square root of 3, which gives you 1 over square root of 3, which is the square root of 3 over 3. Okay? So when we draw our reference angle, and by the way, it is the square root of 3 over 3 because you can multiply the top and the bottom by the square root of 3. So yeah, if this is our reference angle, we wanted the opposite divide by the adjacent. So we want this to be opposite of our reference angle. Let's draw where those are supposed to be too, because tangent is negative. So there's two places where tangent's negative. In the second quadrant and in the fourth quadrant. And tangent theta equals, we said we wanted 1/2 to be opposite of our reference angle. So this is going to be 1/2. And 1/2 always corresponds with 30 degrees like we saw in this triangle that we memorized. So 30 degrees over here. And I think that's enough to answer the question, because this will make the ratio that we wanted. Opposite divided by square root of 3 over 2. That's going to give us negative square root of 3 over 3. let's see. Yeah, that's everything. So now we just need to state the angle. So this is 150 degrees from the initial side to this terminal side. And then let's write that 150, and then we also have 330 degrees.